So now this video discusses on how we can find the number of particles of a substance if we are given the number of moles and likewise. So the number of particles symbolized as N of a substance is given as the number of moles times the Avogadro's number. So this is the formula that is being used to find the number of moles, actually a number of particles. And that can be the number of particles, the number of molecules, let's say ions, and are different what you can have. But this is the formula that is used to have the number of particles. Number of moles should be number of ions, number of molecules, and number of atoms we can have. And where this is the number of moles, that is being calculated as mass over lambda. So in some cases we may be given the mass, but being told to have the number of moles, actually number of particles, we need to understand about how the moles can be calculated in order to have the number of particles. And where this is the Avogadro's number, which is given as 6.022 times 10 to the power 23, can be particles, ions, atoms, molecules, or it depends on the nature of the question as it is. So here's the question. Find the number of, let's say, particles in the following substances. Find the number of particles in the following substances. Let's say we should have number of particles in 2 moles of, let's say, carbon dioxide. So how should you have the number of particles in 2 moles of carbon dioxide? So in this case we have been given the number of moles, which is given as 2 moles. And we know the Avogadro's number is given as 6.022 times 10 to the power positive 23 particles. If that is the case, then it means we should have, the number of particles. That is, the number of particles will be given as the actual number of moles times the Avogadro's number. That would be given as 2 times Avogadro's number 6.022 times 10 to the power positive 23, and that should be particles. So what is that with the calculator? So now for this case, with the calculator, I'll have 2 times. So I have 2 times, and by the way, we should have to present them in brackets. So I have 2 times. That is 6.022 times 10 to the power positive 23. So that will be given as 1 point should be 2 times 10 to the power positive 24 particles. So which means in 2 moles of carbon dioxide we have about such number of particles. You should have to understand. And how about, let's say, in 0.5 moles of, let's say H2, that is let's say sulfuric acid. H2 should be SO4. So how should we have this? Principle remains the same. We have, the number of moles, 0.25, should be 0.5 moles. And we have the Avogadro's number, which is that of 6.022 times 10 to the power positive 23 particles. And we need to have the number of particles. And in that case, how should we have it? Try to have that one. And what if we have been given the mass? Let's say if we have 2 grams of, let's say, H2O, how should we have the number of moles? And how should we have the number of particles if we have 2 grams of H2O? Now we have the mass given as 2 grams, and we have the Avogadro's number, which is given as 6.022 times 10 to the power positive 23, and now we are looking for the number of particles, of which the following number of particles is given as, should be number of moles times the Avogadro's number. So what we need is number of moles, where the number of moles is given as the mass given has to be in grams, and that divided by the lam. So in this case, the lam will be the lam for actually H2O, where you need to calculate the lam for H2O and put it here, and you have the number of moles, then you have it here, you have the number of particles. So keep that in mind. And now, what if we have, let's say, something about, let's say, 200 grams, 200 kgs of, let's say, sodium? How do you think we should have the number of particles in this case? So we have the mass, which is 200 kilograms, but it has to be in grams, by the way. So which means you should have to convert kgs to grams. Then you have the number of moles using the formula. Lam for nitrogen, I should be lam for sodium, like that. And I'll have the number of particles using the formula that you should have to understand. So try to have that one. And in some cases, you can also have to be given, let's say, the number of particles, being told to have the number of moles or the mass as well. Let's say if we have 22 times 10 to the power 15 particles of, let's say, sodium oxide. So what is the number of moles? What are the number of moles that are in this? So in this case, it means we have the number of particles being given as the number of moles times the Avogadro's number. Now in this case, since we have been given the number of particles, we'll put it here, 2.22 times 10 to the power positive 15, like that, which is equal to number of moles times the Avogadro's number, 6.022 times 10 to the power positive 23. So which means the number of moles can be given as 2.22 times 10 to the power positive 15 divided by 6.022 times 10 to the power positive 23. That you can be able to have the number of moles using this case. And of which, when you're bragging on the calculator, you should have to put them in the brackets. So you can be able to have the number of moles in that way. And from there, you can be able to have the mass, and upon having the number of moles. What if we have something about, let's say, if we have something like this? Let's say if we have, let's say, should be 9.92 times 10 to the power, let's say, 30 ions of sodium hydroxide. So in this case, what is the mass of sodium hydroxide, actually of sodium hydroxide, if in 9.92 times 10 to the power positive 30 ions of sodium hydroxide? So how should you have the mass in this? So try to have that one in. And let's say if we also have, let's say, 6.77 times 10 to the power 10 molecules of, let's say, should be about, let's say, hydrogen peroxide. Let's say that is the case. So how should you have the mass in these actually molecules? It should be molecules rather. How should you have the mass in such 6.77 times 10 to the power 10 molecules of hydrogen peroxide? How should you have the mass there? So that's how you start to understand about how we can have the number of moles, number of particles given the number of moles, which is given as the number of particles, given as the number of moles times the Avogadro's number. of which if we have the mass, then we can be able to have the number of moles using the formula given as that, and basically like that. And also if we have the number of particles, we can be able to have the number of moles, and from the number of moles we can be able to have the mass using the formula given as the number of moles times lambda. So this is how you start understanding. Thank you.